we have our distant object at least 6 meters away, and the light rays coming in, they converge right at the fovea like they should, and then you get a clear image. All right, so that's example 1. Now, what if we changed the viewing distance? And we brought what was a distant object, let's say, to 50 centimeters away. So now we have an object. We'll just make a little cross here. And we still have the eyeball, but it's a lot closer now. So light rays coming into the eye, when it's less than 6 meters, the light rays are going to be divergent. So we just draw divergent rays. Okay. Now, when the rays of light coming in are divergent as opposed to parallel, like we see in example 1, what's going to happen is the eye, as you recall from the last video, the eye has a bunch of convergent power. So it will converge those rays to some degree, but it only has the same amount of power that it had in the example where the rays are parallel. So it's going to converge them, but it's not going to converge them right at the fovea anymore because the rays are divergent. So that you can only increase the refraction angle so much. So what'll happen is those rays of light will converge, but they're going to converge at a point behind the retina now. So in this example, you've got an emmetrope, still an emmetrope, but we've moved the target in to 50 centimeters. And we've created like a divergent light coming in. And because the divergent light was coming in, the rays inside the eye are not going to be quite as convergent as they would in the example above. So there's a form. So what we need to do is the same thing that we did in the hyperope when then they were uncorrected and then they were looking at the distant target. It's the same thing. So we need to take the lens from its resting state and we need to change the shape of that lens to a more curved surface. Therefore, once it's more curved, we know that there's more convergent power, and we are able to achieve what we wanted to bring the rays of, or to bring the point of focus from behind to the fovea. So there's a formula to help us figure out how much this person needs to accommodate. And the formula is